And here we are with the last lesson in the topic, functions. We know what scope is, we know what parameters are, we know what procedures are, we know what the term method means. Now we're going to get into the last type of method, which is called a function. And as I mentioned the other day, a function is basically the exact same thing as a procedure, just with a little bit more to it. Not much more. And again, just like last time, we're going to learn how to define it, where to define it, and how to call it within our programs. And again, you already know how to do most of this stuff. We're just formalizing it a bit. So, proper definition for you. Now, if you look at this, it's pretty much exactly the same as a procedure. A function is a mini program within a program that performs a single task. That's the definition of procedure. And returns a result to the programmer. Key there is the programmer. It doesn't necessarily get displayed on the screen. It depends on what you're doing, but it's not the job of the function to display anything on the screen. The job of the function is to do some processing and give you, the programmer, back the result. Now that might be math, it might be something else like string manipulation, it could be something anywhere in between. We don't know. But it gives you some kind of result. And then you as a programmer have options. You could store the value for later use. Maybe that's displaying on the screen. Maybe that's putting it into other calculations. Maybe it's doing something else completely. Or you could use it right there on the spot to display or to calculate or something like that. We've already done this a few times. We'll come back to this actually. But basically, the main time that we use it is whenever we get input from the user. If we're not getting it and storing it as a string, well, that's one thing. We are storing it as a string, first of all. But if we need to convert it because it's a different data type, we might have to use the parse command, like, for example, integer.parseInt, to convert it into an integer right there on the spot. What gets converted? Input.nextLine, whatever the user types in, right? So we're actually doing multiple steps in one single line. Anyways, back to the point at hand. A function is a mini program within a program that performs a single task and returns a result to the programmer. All of our math operations pretty much do this. Math.square root, math.pow, all of our string manipulations, they pretty much all return a new string back to us, right? So when we do 2 uppercase, we get a new string back. And then it's up to us to decide whether we want to store it or whether we want to use it immediately. So how do we actually define a function? So the yellow, just like last time, is customizable. The blue is just to show you the difference between functions and procedures. And you're going to see there's not a lot of difference. So the first thing we see is that signature line again. And the one and only difference here is there's no more void. Void has been replaced by this return type thing. So we had private static void identifier. And void told us that it was a procedure. Well, what's the difference between a procedure and a function that we just saw? Well, a procedure just performs that single task. A function also returns a result. A procedure doesn't return anything. Well, that's where that void comes into place. It means don't return anything. Because void means nothing, less than nothing, zip, zilch, nada. So for a function, we have to specify what type of data we're going to be giving back to the programmer. And then we have the same set of other setups. So we have our identifier, some parameters, whatever else we need. Inside, there's one major change. So we still have our code that is executed fully from top to bottom. This isn't new. But we are going to end with something called a return statement. So we're going to return some value that matches the same type as return type. Now that value could be anything. It could be a literal value. It could be a variable. It could be some form of mathematical expression or anything in between. It must match the same type as return type though. If it doesn't, it's going to complain. Now this return statement, when your program executes this return statement, it immediately jumps back up to where the method was called. Nothing after that return statement will get executed. So if you have code sitting after that, your compiler is going to complain and say that you have unreachable code, because it is. As soon as return is reached, it jumps out and goes back to the rest of the program. Okay. Let's look at a simple example. So here we have one that calculates the area of a floor. Well, most floors are rectangular. So What do we need? We need a length and we need a width. Inside, I've created a variable called double area, and I've calculated it, and it returns that area. Now I want to point out a few things here for you. First and foremost is the fact that area is not one of the parameters. Why is it not one of the parameters? It's a variable. It's a local variable. We need it for the calculation. We do need it for the calculation, but it doesn't support the calculation. It doesn't support the actual work. So the only thing we actually need for the work is the length and the width. So that's why they're parameters. They're required to do the task. Area is just some temporary variable that we're using to store the result of that calculation. So just like before, when we get down to this bottom closing bracket, all local variables are deleted. Length will get deleted, width will get deleted, area will get deleted. The value that's stored in area goes back up the chain, goes back up to wherever it was called. Okay, so let's break this down just like before, same as before. We have our static because we're creating something outside of the main. This time we have a return type that represents the type of data we're going to be giving back. Then we have our identifier, which is descriptive. It tells us exactly what we're doing. We're calculating something. What are we calculating? We're calculating the area. What are we calculating the area of? We're calculating the area of the floor. So that one simple name tells me everything I could possibly need. Calculate floor area. Got it. Okay. Mixed case again. We have our parameters, which represent all required data, so the method can actually do its job. Can't do its job with both a length and a width. We have our code inside, which of course also now has that return statement. Okay, and just like before, as I mentioned, we have this area variable, which is local and temporary, and it does get deleted with all the other parameters. So we know we don't need to define where to do this anymore, because we create our functions in the exact same place that we create our procedures, outside of the main and below the main. That's it. So how do we actually use these things now? How do we use a function? Well, let me ask you this. What do you do when you call math.pow? Where do you put the result? You have to store it. You have to store it in a variable. Well, it's the same thing with any method, any function that you create. If it gives a piece of data back, you need to store it. You need to store it in a variable that matches the same type as the return type. So, using a function is the same as a procedure, except for one major difference. It's our job as programmers to store the result of the function in a variable matching the return type of the function. Okay? So, we need to create a variable. Makes sense. So the next two slides are going to do the exact same thing as last time. We're going to call our function using literal data for the parameters, and then we're going to call our function using user data for the parameters. But I'm not going to go over it in a lot of detail because I went over how the memory management works in the previous lesson, and it's basically the same. So here we have our calc floor area function down below. Now up top, I'm going to call calc floor area, and I'm going to give it a length, I'm going to give it a width, but this thing is going to give me back a double, so I need to store it. So here we see I've created a variable to store the result. I gave it a starting value of 0 just because I like to do that. I like to make sure that my data is always secure. And then here's me calling calc floor area, and I gave it the value 2.5 and 2. So when it calculates this, it's going to be 2.5 times 2, which is 5. So the 5 is going to come back up and then be stored into floor area. Now remember how assignment statements work, how these equal statements work. The entire right-hand side is evaluated for its resulting data. So when we call calc floor area, it gets evaluated to just the number 5. So 5 replaces that entire command, and then the assignment statement occurs. It's basically the same thing as saying floor area equals 5. And so the 5 gets dropped into the floor area variable. And then we just display the result on the screen. There's nothing too crazy here. It's still the same rules. The 2.5 gets copied into length. The 2 gets copied into width. Area gets created, and then it gets the result stored in it, and then we return it back. And as soon as that squiggly bracket is hit, actually as soon as the return statement executes, it deletes area, it deletes length, and it deletes width. Lots going on there. So let's take a look at this big guy. This is the exact same thing, but this time we're getting the data from the user. So just like I did last time, I created a couple variables. I have room length and room width, and these are going to maintain the data that we get from the user. So the user gets to decide what the length and width of the room is. I've created a floor area variable. Oh, this is a no-no. This variable should not be defined here. Where should it be defined? Pause for a second. Where should it be? It should be up top with the other variables. So we should have defined double floor area up here. And this line of code should just be, actually you don't even need this line of code. This entire line of code should be way up top with the room length and the room width definition statements. Okay, but we do still need to call calc floor area. And you notice this time we're passing in room length and room width. So whatever the user typed in for room length, a copy of it is going to be created and then dropped into the length variable. Similar for the width. The work happens, all the temporary data gets deleted, and then that value comes back, substitutes it for that entire chunk, and then it gets assigned into floor area. And then we get to see the result. So that's it. That's procedures. That's functions. That's all that you need to know about subprograms for the foreseeable future. We're going to expand upon it later on, and you're going to really get into it when we get into other courses, the grade 11 and the grade 12. Okay. Well, actually, that's it. For now on, good luck with your assignments, and you should be looking at every problem and saying, should I be using a subprogram for this? Am I doing this more than one time in my program? Is this code too ugly? Should I be pulling it out and putting it into a subprogram? Think about that every time you're writing your code going forward now. Good luck.